Name is Z, and thanks for joining me today. So this is going to be a code along that accompanies a Medium article that I posted about a week ago on the topic of cohort analysis. Cohort analysis is a methodology that you can use in customer or marketing analytics to understand your customer retention, or if you prefer, your customer churn, how fast your customers are leaving you. In the article, I describe the code, and I also provide a GitHub repository where you can play around with the notebook that has the code. But in this video, we're going to be actually walking through the code in full, and let's get to it. So this is not going to be super complex. So it's a lot of data transformation. So we're just using good old pandas and NumPy with some matplotlib and Seaborn for visualization. So let's just import all of that. And the next bit is actually this custom class that I've written. So it is very long, but the whole intent is that it abstracts away the problem of manipulating the data. So rather than having a transaction table and having to sort of run through all the steps, the custom class takes care of that problem and provides you with a simple way of, you just call a method and it will produce a series of charts, answers, whatever it is that you need. And we'll walk through it in a moment. So for now, what we will do is we'll just load up the custom class. And now we will start looking at our data. And what we'll be using is a data set that's on public domain provided by KPMG. And it is a fictional company called Sprocket Central, which is a SME that does bicycles and bicycle parts. And this is a year's worth of data that we're going to be playing with to help kind of illustrate how the custom class works. So let's go ahead and load up the data. And we will take a look at the data as well. So the data is a table of transactions. As you can see, it's got transaction ID, it's got customer ID, it's got list price, how much how much it was paid for that item. It's got the 20,000 rows to it, so 20,000 transactions in that 1 year. Let's have a look at the data types. Important is the transaction date, which is in a date time format, which is what we want. If you're doing this yourself, you need to watch out to see whether it comes out as an object. Then you need to convert it into a proper date that pandas can work with. And we're going to also look at the any none fields, so blanks. There are a couple of blanks. So you can see brands being blank, products being blank. So let's just throw those out. So there are 555 rows out of 20,000. Let's toss those out. And this is now going to be our transaction table. So this is what we're going to feed the custom class so that we can start generating some insights. We will also need some demographic information. So this is also part of the data set where you have about 4,000 customers and information around their names, industries, job titles, and let's just look to see if there are any blanks. There are a few blanks in the date of birth and age, but let's just keep everything in because we won't be using age as a demographic criteria for the analysis. So the next bit is we need to create the custom object. And the way we do that is let's look at the fields in the input table. So we've got transaction ID, product ID, customer ID, and we need to instantiate the class. So it goes all the way back up to the top where you instantiate the class and you need to provide it with some information like the data frame, that is the input data frame, your order ID and your transaction ID. So order is basically something that you place that has items in it. So a single order may have multiple transactions. And then customer ID is a unique number for your customer, the timestamp, how much each transaction is worth, and the granularity, and you've got granularity going from days to weeks to month to quarter to years. More on that in a little bit. So let's just go back down to where we were a moment ago. And we need to instantiate the item. So let's just start with month start. So we're going to do transaction ID twice. Now you might be saying, what's going on here? It is because in this data set, the transaction table is such that each line is already an order. So they don't have an order with multiple transaction lines. Each line is an order and a transaction in and of itself. So I'll show you an example later where it's a bit more complex, but for this one, it's we're going to repeat transaction ID twice because the transaction ID is in effect the order ID as well. So let's just set it up. And for demonstration purpose, we'll also have another item that we'll do as weekly, and we'll come back to this later. So one of the things that you can do is you aggregate that data. So remember, 20-ish thousand rows, so minus 555, so 19,000-ish rows. We are going to aggregate the information down to the monthly level. So we fed it with MS, which stands for month start. And you notice that transaction dates are all beginning in the first of the month. And you might be saying, oh, that's wrong. I thought I saw other dates. The reason being that we've rolled it all up to the start of the month. You can also pick month end, but let's go with month start. And the way to interpret this is if you look at the actual raw table, you will see that this customer, 3486, has multiple transactions. And in the month of December, they actually have 2 orders and 2 transactions. So again, one order was 1 transaction. So you notice that these were the dates: 27th of April, 24th of June, 9th and 21st of December. But when you roll it up, it essentially collapses these two into a single line item. So you only get one line item saying that in the month of December for that particular customer, you spend 2,000. So, did the customer buy in that month? Yes or no? Because you've done it in the granularity of month. You can, of course, do it more granular, and I'll show you a moment why that sometimes is helpful, but why sometimes that's not. But for the rest of this exercise, we will stick with monthly. So once we have the object instantiated the way that we have, you can start doing a couple of interesting things. So you can start looking at, I want to know how much revenue I'm getting per period. I know I called it spend, but it actually means, how much are customers spending each period. And what you do is you use the word plot, and you use the keyword spend by period, and you use the method called spend by period, and you don't have to feed it any input. If you run this, it will produce a table and it will show you how much spend in every month aggregated. And you can also look at how many customers are active in that period. So this is the count of how many customers made a purchase in that particular month. And it also looks out for new customers, meaning customers that have only been seen during that month for the very first time. And you can see from the chart that the first few periods look as if everybody is new. So this is a bit of to do with the data set itself, because you only have 12 months of data. So it's very likely that they were not new customers. And these are actually rollover customers from a data set that we can't see in the year before. But what we are able to observe is that there aren't many new customers towards the tail end of the year. And that's kind of concerning, because if you want to be a business that grows, you do need some new customers coming in, because you're going to be losing customers as well. So remember I said that you can look at information at different granularity. So here's an example where we're going to call the same thing, but we're going to put W for a week, and we're going to plot exactly the same thing that I showed a moment ago, but now it's on a weekly basis. So it looks kind of like this. And you can see it's 52 weeks. It's more granular, but it actually makes it worse because it's harder to tell what's going on. So you can, of course, drill down or drill up any which way you like. And we've just chosen to stick with month for now. In fact, actually, just as a demonstration, you can also do quarter start. It will still say week, but let's just leave it for now. If you do quarter start, you can actually even look at it from each quarter. So again, the choice of granularity really depends on what you're trying to do. For cohort analysis, depending on the business and the nature of the transactions, monthly usually works. So we get into this bit of understanding, trying to understand who are the new customers and how frequently customers, what is the rate that the customers are leaving. So you might say, well, we already have this chart that shows, that you have maybe 1,000 something existing customers and 100-ish new customers in June. So why can't we understand the retention from the months gone by? And the reason why you can't is let's just pull up some numbers. So first, we're going to use a method to look at the first and last transaction by customer. And we are going to kind of observe the June customers. So this is the customers that made a purchase in the month of June. And you have the customer ID, you have how much they bought. And because we also have a method in the custom class that looks at the earliest and last transaction, you can actually pull up the earliest transaction, which we will call the join period, the first time the customer has actually made a purchase. So you can see that in that particular month of June, so let's just pick the middle of the year, you have customers that are brand new, 128. But of the 1,000-ish customers that you had earlier, they all come from different months. There were some customers from May, some customers from April. And what you really would want to do is actually track the customers from the time that they first join all the way to the time that you're observing. And that's hard to do when it's all blended. So cohort analysis is a way of actually trying to split that up. And the custom class has a very nifty method and also an automatic plot where if you put cohort by acquisition period, meaning the date that the customer first joined, so it can be by month or by week or by quarter, depending on what granularity you set, it will automatically generate for you the cohort analysis for retention. And what this chart shows, it's worth explaining, is you have a time step, you have the cohort period, and then you have the percentage of customers from that initial first step, how much of them are continuing to buy over time. And you can kind of see that you have people who bought in January, there is a bit of a reduction, but the big one actually happens in the first step. And in some cases, you have this weird thing where the number actually shoots up, and that's because these customers were not buying in the second and third time period. So they joined in April, May, June, July. They didn't buy anything in May and June, but then there were some that actually reappeared in July. You thought they were gone, but they are back again. And it gives you a way of understanding what is the retention over time by the customer cohort. So again, this is just a sample data set. But the idea is that the custom class does this for you almost automatically. Now, you can also observe the same thing in a absolute basis, where instead of actually showing it in the blank, you put in the keyword ABS. And what that does is that produces the absolute numbers, meaning that instead of percentages, you say that there are 1,000 customers that joined on that date, just like how in June we said there were 100 customers, and you can see how many of them come back. And immediately when you look at absolute, you see something weird going on because there are not that many new customers. So this whole percentage thing is useful for normalizing, but you sometimes need to look at the absolutes as well. And you can also, if you're interested, also look at the cohort spending by over time. So it's the same principle for that cohort. How much did they spend over time for each time step? And the beauty of doing it this way is that you don't have to do any of the data manipulation because it's handled by the custom class. Now, in addition, what I've also provided is a means of doing the same thing, but through customer attributes. So instead of looking at the time that they first made a purchase, their cohort join date, you can look at it from the perspective of the demographics. So you feed it the customer demographics, invite customers. You pick the field that you care about. And in this one, we're going to pick industry. And what it does is that it produces the retention by month by the industry. And you can do the same thing. You can look at the information in a table form, and you can also look at it in an absolute form. And again, absolutes matter because you can see the lion's share actually comes from manufacturing, and you may really want to think about whether telecoms deserves a lot of analysis because it is by scale a lot smaller. So the other useful things that the custom class does is it also provides you with a means of looking at average retention by time step. So rather than look at all the different cohorts or different demographics, you can look at it just as a simple aggregate retention by time step in absolute terms. So how many customers over time by the respective time step, regardless of when they join. You can see that there's a huge drop in the first month. And you can also look at the total number of customers by cumulative transaction count, where what this chart shows is that there are 10 different if you go by a monthly frequency, there were some customers who went up to buying 10 times in those 12 months, but only 5 of them. And this thing is the cumulative picture where at least 3,400 customers had one. But if you go down to say like at least 2, you get 3,400. And if you say how many made 6, it's only 878. So this is the way to interpret this chart. It also shows you duration between transactions. And what I mean by this is it shows you the time between the first and second and third transaction. So between the first and second, it's 2.5 months. Between the second and third is 2.4 months. And you notice that it gets more frequent as you go to the higher frequency purchases, where the time between purchases is more like a month. But again, you need to be mindful of absolutes because you can already see the number of customers who bought frequently a lot smaller than the majority. So you do have this kind of a masking effect where these guys were probably all buying every month. It's just that you can't see it because the earlier numbers were driven by the 3,000 or so other customers. So that is some of the stuff that you can do. I also have a additional feature where rather than look at is the customer who joined at this period buying again in a certain time step, you can ask the custom class to look at the active period upon which beyond the customer is assumed to have left. And what I mean by this is you assume that the customer can, if you don't have a purchase for more than 15 days, say, for example, the customer is gone, and what you do is you use customer acquisition by inactive period. You key in the inactive period and you key in the expiry date by customer. It will generate the same information that you saw a moment ago, but now instead of looking at the in-between purchases, it's actually going to ignore all that. It's just going to look at the last day that the customer was seen to have made a purchase, and then it just says, let's add X amount of days to it. So in this case, it's 15 days. And it says that that is the period beyond which the customer is no longer active. And you get a slightly different view of what the retention looks like. And you may want to go down this route if you just want to, you don't think that the purchasing behaviors are true reflection, especially in the early periods. So this is showing a kind of a rosier picture where you've got it still ends up as 37 at the end, but you can see that the rate of decline is more gradual because the customer is still seen to be there. So it's just a different way of looking at the same information. And again, if you want to look at absolute terms, this thing also provides that by using the keyword apps with the method. Now, that is more or less the core functionality that custom class provides. It also has a ability to go into something called recency, frequency, and monetary analysis. So for this one, it's a bit weird to do it on a monthly basis. I mean, you can, but typically you do it on a day basis. So we're going to create a new object that is granularity in days. And similarly, it takes away the challenge of having to manipulate all that data because it provides it in a day granularity automatically and in RFM. And just to show you the difference between days and months, in the earlier analysis, we actually had the same chart. I think that was up here somewhere. Let me just find it, where it was showing the details on a month-by-month basis. And you can see we had some customers who bought 10 out of 12 months, and it kind of looked like this. But if you go down to the granularity of days, you can actually see that there were customers that bought 14 times throughout those 365 days. So you need to really be mindful of the time granularity that you've chosen. So in any event, as I was saying, this thing has a method that allows you to look at the RFM, recency, frequency, and monetary value automatically. And let's just do that. So it says this customer has this frequency, recency, and monetary value. And you do this because it's handy for customer segmentation. So this is a bit of an extra feature, and I actually do have an associated separate article on customer segmentation using RFM. And it does some automatic plotting as well if you use the word plot and RFM summary. So that's basically a walkthrough of all the functionality that this custom class can do. And the good thing is it's actually semi-automated. So this is a separate data set, and we're not going to go through the same level of detail, but if you actually look at the notebook, you will see that it's actually almost exactly the same piece of code. The data cleansing is a bit more involved. And in this particular case, this is a online e-commerce data transaction set. You can see that this one actually has invoices, and each invoice, same invoice, can have multiple transactions. So this is what I meant when I said that this is a more complex data set. And you can see that here you've got an invoice, sort of your order ID, and if you've got transaction ID, which is the more granular level. But the rest of the code is actually exactly the same. And it takes away the challenge of having to sort of manipulate the data again and again, because you just hit plot whatever you want and the method that you want, and it generates that information. So this is an example where the data set is a bit longer. So I think this one is 2 years and a bit. And you see it automatically pulls out the data for you. And you can pick out the patterns that you want. Now, it should be said that cohort analysis shouldn't be used by itself. It is always a starting point for understanding your customer retention behaviors, you normally combine it with other things. Maybe you've got a data set that talks about customer feedback, maybe you've got some sort of customer satisfaction index, and the idea is you can combine these two things, because cohort analysis is really useful to tell you things like, at what rate is a customer leaving. But if you want to sort of dig deeper, you need to find other data sources to sort of combine it with. Having said that, I really do hope that this is something that someone out there finds useful. Be my guest and fork this repository, make use of this custom class if you want to use it and build it into your own applications, and let me know how I can improve it. I think that was more or less it. So if you have watched all the way to the end, thank you so much for paying attention. Don't forget to like and subscribe, and I will see you next time. Bye.